What is the difference? Engineering stress versus true stress. Imagine you're stretching a rubber band. As you pull, it gets longer and thinner. Now think about how the forces inside that rubber band change as it stretches. That's what stress is all about. When engineers study how materials handle loads, they look at stress to understand when and why they might break. But not all stress measurements are the same. Today, we're going to find out what sets engineering stress apart from true stress and why that difference matters. Engineering stress is the simpler way to measure stress. You take the force you apply to a material and divide it by the original cross-sectional area before you start stretching it. This method assumes the area stays the same, even though in reality, the material often gets thinner as it stretches. It's like measuring the weight of a box by its initial size, even if the box gets squished or stretched later. Engineers like this method because it's straightforward and works well for small deformations or initial testing. True stress is a more precise way to measure stress. Instead of sticking with the original size, it looks at the actual real-time cross-sectional area of the material at each moment during stretching. As the material elongates and narrows, true stress accounts for this change. It's like weighing the box as it gets squished or stretched, giving you an accurate picture of the forces at play at every step. This method is especially helpful when the material is stretched a lot, close to breaking point, because it shows how the stress actually increases even after the maximum point seen with engineering stress. Understanding the difference between these two is key when studying material failure and mechanical breakdowns. Engineering stress can underestimate the true stress in a material once it starts to stretch significantly. This is because it doesn't consider the reduction in cross-sectional area. True stress, however, reveals that the material continues to experience higher stress levels even after the engineering stress peaks and begins to fall. This explains why some materials can carry loads beyond their expected strength before they finally fracture. To sum it up, engineering stress is calculated by dividing the force by the original cross-sectional area, making it easier but less accurate during large deformations. True stress divides the same force by the actual, changing area, providing a more accurate picture of the stress inside the material as it stretches. Recognizing this difference helps engineers predict when and how materials might fail under load, leading to safer and more reliable designs. It's all about understanding what's really happening inside the material as it faces stress and strain.